Hello everyone and welcome back to the channel. Today is 2025, September 19th, a lovely Friday. I'm here to introduce a super interesting trending article from the archives that's been making some waves. Alright, let's dive right in. So I was digging around and found this gem. The title is CS-FLEURS, the massive multilingual linguistic speech dataset. Curl is Spetseed or Chi 2509.14161 volume. It's long. Okay, so what is this all about? Well, it tackles a problem that's super common in real life, but that our smart assistants and voice tech are honestly pretty bad at. It's called name switching. You know, when you're talking to a friend and you start a sentence in English, why do you finish in Spanish? Or you mix Japanese and English words together in one go? That's that switching. Billions of people around the world do this every single day. It's totally natural for anyone who speaks more than one language. But here's the problem this paper is trying to solve. RA models, like the ones in our phones or smart speakers, are mostly trained on monolingual data. Meaning, speech that's purely in one language. When they hear mid-sweet speech, they just get completely confused. They might transcribe it as gibberish or just miss half the sentence. And why is that? Because there's a huge lack of data. Think about it. Collecting natural tweets and conversations is incredibly hard. You need to find bilingual speakers, record them in natural settings, and hope they do nab switch in a way that's useful for training. It's slow and it's hard to do for hundreds of languages. And so the researchers behind it, they said, what if instead of trying to find this data in the wild, we just make it ourselves? And that's exactly what they did. They created this massive dataset called CS-FLEURS, which covers 52 languages and 113 different language pairs. That's huge. Their approach is super clever. They use something called the matrix language front model. Sounds complicated, but the idea is simple. The language, when matrix language, provides the main grammatical structure of the sentence. We call one the matrix language, which is weird, because I didn't see Neo or any spoons involved. Just a lot of grammar. Anyway, then you take words from a second language, an embedded language, and you pop them into the sentence. For example, you could have a German sentence as the matrix, with English words embedded inside it. So how did they actually create the audio? This is where it gets really cool. They did it in a few different ways. For a small and high-quality set called Neutrals Red, they used a powerful language model, GAFORL, to generate really natural-sounding dead switches. They've even prompted it to create what's called morphological data switching. That's when he mixes languages inside a single word, like their example taking the English phrase and freaked out and turning it into the Spanish-style word chiquillo. How cool is that? Then they had actual bilingual speakers read these sentences out loud. So you get real human voices speaking these synthetically created sentences. Right in that for 113 language pairs would take forever. So for the rest of the dataset, they went fully synthetic. They used a simpler, but more scalable method called align and swap. They take a sentence and say Hindi, and its English translation. An AI would align the words like kak in English to believe in Hindi. Then, it would randomly swap about 30% of the keywords, like nouns and verbs, from English into the Hindi sentence. This method is less fancy, but it's super consistent, and allowed them to create data for tens of languages, including many that are considered close to horseshoe. And they used text-to-span models to turn all this text into audio, so they ended up with this giant, diverse dataset of sweet speech. Okay, so I made this amazing dataset. What did they find out? Well, they tested OpenAI's famous Whisper model on it, and the results are fascinating. First, Whisper really struggles with transcribing its speech. Its error rate was more than twice as high compared to when it listens to just one language. No big surprise there, I guess. But it got way worse when the two languages used different scripts. Back say Arabic in English or Korean in English. The error rate was, on average, 3 times higher for those pairs. It seems like asking the AI to jump between different alphabets in one go is just really, really tough. But here's the most surprising part. While Whisper is bad at transcribing the NetSuite speech into text, it was actually pretty good at translating it directly into English. In some cases. It was even better at translating the mixed language audio than it was at translating the original monolingual audio. That suggests that for AI, skipping the transcription step and just going straight to translation might be a much easier path. That's a really insightful discovery. And finally, they showed that training an AI model on their synthetic data works. It improved the model's performance on speech, not just for the language pairs it saw during training, but even for new and seen language pairs. This proves that their synthetic data is genuinely useful for making nice model. So what does this all mean for our everyday lives? The applications are actually huge. Let's think of a few. Voice technology and our virtual assistants. Imagine being able to talk to Siri or Alexa naturally, without having to stick to just one language. You could say, "Enable me to call my Abdullah tomorrow," and it would just understand. This would make these devices so much more accessible and useful for millions of bilingual people. Second, let's talk about gaming. In online multiplayer games, you have people from all over the world on one team. Base chat is a mess of different languages and then switching. With technology trained on Dataset like CS-FLEURS, you could have real-time subtitles or translations that actually work, making teamwork smoother and the experience more inclusive for everyone. And a third example is customer service. Automated phone systems could finally understand customers who leave in switch, which is super common. Instead of the frustrating sorry, I didn't get that. The system could understand your mix of languages and get you the help you need faster without needing a human. Compared to other technologies, the old way was to collect small, expensive datasets of natural speech. That's great for authenticity, but it just doesn't scale. This paper's approach in generating synthetic data is again major. It's a practical, scalable solution that lets researchers and developers finally start tackling the NetSuite problem for a massive number of languages. So yeah, this stage data is a huge step forward. It's helping us build AI that understands how people really talk, not just how we think they should talk. It's making voice technology more inclusive, more powerful, and a little bit more human. That's all for today, but a fascinating piece of work, right? Let me know what you think in the comments below. Thanks for tuning in, and I'll catch you in the next one.